Physics Part 347. An EMF is not induced when the wire is held stationary between the pole pieces. An EMF is not induced when the magnet is moved so that the pole pieces move along the length of the wire. An EMF is not induced when the wire moves lightways so that it does not change its position between the poles of the magnet. The observations lead to the conclusion that an EMF is induced whenever lines of the magnetic flux are cut. The cutting may be caused by a movement of either the wire or the magnet. The magnitude of EMF is also observed to vary. The magnitude of the EMF increases as the speed at which the wire is moved increases. The magnitude of the EMF increases as the speed at which the magnet is moved increases. The magnitude of the EMF increases if the wire is made into the loop with several turns. The magnitude of the EMF increases as the number of turns on the loop increases. It can be concluded that the magnitude of the induced EMF depends on the rate at which magnetic flux lines are cut. The rate may be changed by varying the rate at which the flux lines are cut by a single wire or by using different number of turns of wire. The two factors are taken into account by using the terms magnetic flux linkage. Change in a magnetic flux linkage is equal to the product of the change in magnetic flux and the number of turns of a conductor involved in, in the change in flux. Change in magnetic flux linkage is delta N. The experimental observations are summarized in Faraday's law of electromagnetic induction. The EMF induced is proportional to the rate of change of magnetic flux linkage. The experimental observation made with the apparatus of the figure and have been concerned with the magnitude of EMF. However, it is noticed that the direction of the induced EMF changes and that the direction is dependent on the direction which is the magnetic flux lines are being cut. The direction of the indeed EMF or current in a wire moving through a magnetic field at right angles to the field may be determined using Fleming's right-hand rule. This rule is